right, APC, we're going to finish up 6.5 in this video. We got to the observations on the last one, and so we're going to pick up. So all 6 functions, observation based on the graphs, all 6 functions are periodic, which means values repeat at regular intervals. Okay. The period for sine, cosine, and cosecant is 2 pi, while the period for tangent and cotangent is pi. And this is because of that tangent and cotangent being positive in that 1, 3 difference of 180 in the quadrants, and 2 and 4. And that takes care of that, you being able to have them repeat in pi versus 2 pi. And yes, I know sine repeats itself in 1 and 2, and then 3 and 4 repeat, but there's no way to write that succinctly like it is here, because it's not every other. Same thing with cosine, which repeats itself quadrant 1 and 4, and quadrant 2 and 3, but I can't just write that to encompass both of those. So 2 pi and pi. So based on this definition of an even function, when you plug in a negative angle for trig functions, you get the same result as a positive angle. So that would happen, for cosine, it's going to have positive, and when it goes negative, it's going to be positive. So you're going to get the same result. That's even. And then when it graphs out on the coordinate plane, it's symmetric with respect to the y-axis. And that's going to hold for cosine, and of course its reciprocal, which is secant. The rest of them are odd. If you plug in a negative, you get the opposite of the positive. And that's symmetric with respect to the origin. All right, so again, if you sine's up here, and if you do the negative angle, you're going to get the negative result of the positive angle. And so that's odd. And if it goes out on the coordinate plane, that's going to be symmetric with respect to the origin. All that is consistent with your polynomials. So this is for sine, its reciprocal. I'll just write it out. Tangent and cotangent. Okay, what's the amplitude? So amplitude is height. So what's the height of tangent, cotangent, secant, and cosecant, which all involve asymptotes? And this is going to be none, no amplitude. Okay, no amplitude here. And if you think about height, that should make sense. So be careful. If I say y equals 2 tan to the x, amplitude equal to 2, no, it's none. Because the tangent graph is like so, it has no height. So be careful of that tricky question. Okay, let's fill in this chart. Domain for sine, no asymptotes, all real numbers. Cosine, no asymptotes, all real numbers. Rest of these have asymptotes, so we're going to have to make a disclaimer, which is a domain restriction. Okay, so you think about cotangent first. It's the easiest. Cotangent has its asymptotes at the beginning and the end of the period. So that's at 0 and pi. So t can't be any multiple of pi. 0, pi, 2 pi, 3 pi. And then I always sort of think, well, this cosecant behaves that same way. The 2 cofunctions have that. This is just memorization technique, so those are the same. All right. And so if you think about it, cosine is the reciprocal of sine, and sine is 0 at 0 pi and 2 pi. So if you reciprocate 0 at pi, 0 pi and 2 pi, then you're going to get undefined, and that would be an asymptote. So those are the same. And then tangent has the asymptotes at a half period. So that would be at pi over 2, and to get to the next one, you go by the period and then n, and this is going to be the same as secant. And so just duplicate that, okay? And so for tangent, the asymptotes are at like, they're on either end of a period, okay? So they're at half a period, right? But the next one would be at the period of pi, whereas with secant, the asymptotes are every half period. So we're adding pi here because that's the period. That's how asymptotes occur for tangent. But we're adding pi here because asymptotes occur at every half period for secant and cosecant. So it's just nice that we can find some consistency in how we write it. If you can just think about it, great, but if you need some memorization techniques, that's kind of how I would go about thinking about it. The range here, sine and cosine are in between -1 and 1. Tangent is all reals, as is cotangent. And then cosecant, I've got to leave out that middle part, right, from in between -1 and 1. Same with secant. So this is -infinity to -1, union, jump to 1, and head to the infinity. Same with secant. -infinity to -1, inclusive, union, inclusive 1 on to infinity. All right, as forementioned, all these periods are 2 pi for sine and cosine and their reciprocals, but tangent is pi. So it's cotangent. And this is odd. Cosine is even. Tangent is odd, and so go their cofunctions. Odd, even, odd. I think we've discussed that enough. So there's kind of a little summary chart. Okay, next page. Okay, this top part is pretty easy. Just going to list transformations as we would in with polynomials. All right, so first one here, this is just a vertical shift down 2. And we're going to think about that the same way we would as polynomials. This is going to be a vertical compression by 1/2. And so even though, you know, I don't want to use amplitude here because cosecant doesn't have an amplitude, but we'll more be looking at that 1/2 in terms of amplitude. So for sure, for sine, the amplitude would be 1/2. And for cosecant, that would be where that U shape kind of has its minimum and where it has its maximum. It's not an amplitude, but we'll use it more of getting the appropriate place for the vertex of those U shapes. We won't really think about it that much as a vertical compression. Here, this will be a horizontal shift left 1, and you'll see in 6.6 we'll think of that as a phase shift. And then here, this is a vertical reflection over the x-axis. And so what we'll think there more than a vertical reflection is we'll think, okay, we're going to use cosine to guide us at secant, and cosine is going to start low. That's what we'll think when we think here versus a vertical reflection. And then we'll remember to actually graph the secant. And then, of course, a horizontal shift right 3. All right, so this is easy. Let's just do the prompt in reverse, and then we'll do some graphing. Let's graph secant stretched vertically by a factor of 2 and shifted down. That's easy. Done. Vertical shift is a times 2, and a down one is just -1. Cosecant reflected, and then shifted to the right 4, so in comes the parentheses, and we do the opposite sign. So reflected, got it, right 4, got it. All right. Cotangent, shifted pi over 4 to the left and compressed vertically by a factor of 1 over 3. I mean, I can't even really see that. Yeah, 1 over 3. Cotan, and to the left. All right, so now let's actually do some graphing here. All right, so that was easy. Let's do some graphing. And let's start with this super easy one, 1/2 cosecant. So I'm going to use that 1/2, 1/2 here to guide me on sine. Okay, and so sine starts in the middle. Okay, and it's got its asymptotes. I'm going to label them up here because I need room. Typically you label them at the bottom. But okay, and so we'll just make our U shapes. That's dipped a little low. I want it to be it right here. Okay. I'm going to make that really kind of short because I want to have room here. And that's it, okay? That is the graph of our cosecant with a vertical compression of 1/2. That's a minimum value, that's a maximum value, and let's move on to the next one. Okay, so the next one is way more complicated. So let's start maybe with the period. Okay, instead of thinking of this as that's pi, so that would be 1 over pi, 1 over 3.14, so that'd be a compression by 1 over pi. Instead of thinking of that, let's just do our period work. So period is 2 pi over b, that's the b value. So period is 2 pi over pi, and that's 2. So I'm going to just go ahead and go over here and go 2, 1, 1/2, and 3 over 2. Okay, so that takes care of the horizontal stuff. So now let's go to the vertical stuff. So my x-axis is set. So I'm going to head to kind of the chart for figuring out what to do. So let's just do my t values. And you don't have to do a chart, you guys. It's just if it's helpful. So we have 0, 1/2, 1, 3 over 2, and 2. All right, so that's done. That's done deal. So let's go ahead and use cosine here. Let's put our guide in here. So cosine would start high, 0, low, 0, and 1. Okay, so then let's go to our secant. So it would be 1, undefined, -1, undefined, 1. Well, now let's reflect it. Let's do that negative. Still with the negative. So that'll be -1. Can't really negate undefined. That'll be +1. Can't really negate undefined, and -1. And then let's do, times 4. So that'll be -4, undefined, 4, undefined, -4. And then let's do our +1. There's a lot going on here. You've got a reflection, stretch, and a shift. So this will be -3, undefined, 5, undefined, and then -3 again. So it's pretty important to go to secant right here to get those undefined, because if you didn't go to secant right away, you'd be getting different values here, and then they wouldn't undefine when you flipped them, right? So if you, I guess really with the shift, if I shifted that +1 when I went to flip it, it wouldn't be undefined. So it's, if you're using cosine, it's really, you have to go right to the places where undefined come in so that they don't get affected by anything. Okay. So, looks like I'm going to be, let's put -3 right here. So this would be 3, 5 would be about right here. And you can see the equilibrium will change. It'll be a +1 now. I'll go from 0 up 1. Or you can think, well, this is a difference of 8. 8 divided by 2 is 4. So go down 4, I'll be at 1. Or come up with -3, I'll be 1. Either way, this is that equilibrium line. So cosine, if you're just thinking about it, cosine starts high, but now it's going to start low. And that makes sense if you're plotting this point against this point, which you are. If you're doing here to here. Okay, so you get 0, you're at -3. Perfect. On cosine. And, this, we're going to go at that equilibrium line. It'll be up. 1, 5, back, and then down. I'm going to dash this because this is not really this is a guide. Okay, let's put in our asymptotes. So your asymptotes are going to be, since it's been shifted, the asymptotes are going to be where it crosses the equilibrium line. Even though that's not 0, it used to be 0, and that's where you want your asymptotes, at 1/2 and 3/2. Okay, and so we're ready to graph our 0, -3 is here, and the U shape goes down toward the asymptotes. At 1, we're at 5, we're going to go up. And then at 2, We're at -3, and we're going to go down. So there's that graph. Okay, the last one is way easier. Negative cotangent of t over 2. So this negative here, so cotangent is like so. All right, and when cotangent reflects, when cotangent reflects, when this reflects down and this reflects up, it actually, you guys can't really see that, it actually looks like the, well, let's graph up. It's going to look like, okay, it looks like the tangent graph. Which is nice. All right, and so I'm going to just, note that I'm graphing cotangent, but it's going to actually the shape is going to look like tangent. Okay, and so remember cotangent has its asymptotes at the beginning and the end of the period. So I'm going to compute my period. Now be careful here. This is cotangent, and that over 2 is a 1/2. Okay, that's a 1/2. So sometimes students think the b value is 2, but remember the b value is 1/2. So period for cotangent and tangent is pi over b. Period is 1/2, so period is now 2 pi, which makes sense. That would be a compression. 1/2 would reciprocate, so it would be a compression. 1/2 would reciprocate to a 2, which is a stretch, and that's stretching the period of pi by 2. Thank you, James.
You're welcome.
Thank you. So that's 2 pi. Okay, that makes sense. So I'm going to go here, all the way over to 2 pi. Okay. Oh gosh, you can't see that. So 0 to 2 pi. And we're going to make our curve. And so again, this is going to mimic tangent. So instead of coming on a decrease, it's going to be increasing. And I do want to put this point in here at, that's pi over 2, 3 pi over 2. I want to put this point in where it sort of begins to, this key value where it's heading toward that POI and beginning to change its concavity, kind of coming in to begin to start being concave up. All right, last piece here before we get to 6.6. Okay, so, what is this? This, to me, looks like tangent. You could say from the last example, you could argue that it's negative cotangent. All of that's fine, but why would you complicate your life? It looks like tangent. Let's let it be tangent. All right? And it's tangent in the correct increasing direction. So we're going to go with that. Now, this key value here is right here. Okay, that's where we're coming in and beginning to approach the point of inflection and begin to make our change in concavity. And you're going to know where to get this, quote-unquote amplitude. Tangent does not have an amplitude, but that coefficient in front, you're going to see that on the y value. And you can be confident that that's the intent. No tricks there. That's the intent, that would be that coefficient there. And then I just need to see, this is a full period. Remember, tangent and cotangent both have their asymptotes at either ends of a full period. Cotangent is at the beginning of the period and the end, and tangent goes from half period to negative half period, if that makes sense. Either way, you can hopefully see that this is a period of negative pi to pi, which is 2 pi. So let's just get that b value. You can probably guess that it'll be 1/2 because this has been a stretch, which comes from a reciprocal of 1/2. That's not a compression, that's a times 2. But anyway, your formula won't let you down. Okay, so we know the period is 2 pi. Okay, so b is going to end up being pi over 2 pi, which is 1/2. Okay. All right, and then this next one. So some people are going to see sine here, but if it's sine, it's been shifted. And I don't want to do that. I want to keep my life simple. So instead of seeing sine, I'm going to see cosine starting high. And what you want to do, you guys, is complete the period. So that's not it. Go ahead and complete the period. Let's assess. That's okay to add on. These graphs are infinite. So if you can always start at 0, meaning did the graph start high, low, or at the equilibrium point, I would start at 0 and assess which function is here. Okay, so this is going to be cosine. Let's start. It's normal, well, it's not going to be cosine, it's going to be, but the guide is going to be cosine. When all is said and done, it's going to be secant, and you want to make sure you don't forget, after you focused on cosine, you don't forget to grab secant, but the guide is going to be cosine. And then its amplitude would be pi for cosine, the guide, not for secant, because the guide is starting high, okay? And then, this will be secant. I have symmetry here, so no vertical shift, and then I just need to pick up the period. Okay, so this is the start, and this goes all the way, and it looks pretty much like it's 8, okay? So period of 8, but I don't really like pretty much looks like. You know, in math, you don't want to say, oh, pretty much looks like. It's never a great idea mathematically to say that. So what you can do, since cosine and sine are just shifts of one another by nature, you can say, okay, this makes me nervous. What else can I do? Well, you could go back and shift to this sine and show the whole cycle of the sine graph. So for this particular graph, if if you thought of it in perspective of sine, if that has a period of 8, which it does, -2 to 6, then so well the cosine perspective. So now you can have confidence here. And so 2 pi over b shook out to be 8. 2 pi is 8b. Divide by 8. Pi over 4 is what goes in there. All right, there you go. Oh, not b, t. B is pi over 4. The angle is t. Okay, all right, so that is 6.5. Hopefully that's helpful for those of you who are making up your test from being out. And we'll move on to 6.6 next week. Bye, guys.